Okay, guys, hello. So today we're going to be learning about angles and the different forms that we have for angles. So it is important for us to remember the names that were given to some angles, and we're going to review the ones that is mostly more common. That the ones that probably you remember. I don't know if you learned them in elementary. I want to say that, and it's very important for you from now on to understand them because you need to, before you start classifying an angle, you really need to identify them by their name. So that way you can give them a name. And then from there, if you're giving a problem, you need to solve it. So you already know what will be the measurement, in particularly for a specific angle. Just remember that an angle, it's composed of one ray and the second ray. So it is two rays that they're joining at this point, at the vertex. So on this union, that is where you will be finding, this is where you will be finding your angle. So also you will be labeling as angle ABC, or you can label it as CBA. If you notice, I always put in the middle the angle B. Why? Because if I'm referring about the angle, then it should always be in the middle of my lettering. Let me see if I can do measurement, angle B. This is supposed to be a smaller limb. Okay, let me write again. Excuse me. Measurement of angle ABC. This is what I mean. It has to be in the middle in order for you to continue understanding. So that way, not understanding, excuse me, when you need to continue labeling or indicating where's your angle located. So let's see. Let me erase these. And these are the most common ones that we have. The acute, that is less than 90 degrees. And obtuse, that is greater than 90 degrees. A right angle, it's exactly to 90 degrees. And from now on, every time you will be given an angle just like this one with a tiny square, the one that you see here, that one you will assume that it's a 90. Now, if it's not given to you, do not assume. You really need to look at the instructions they're providing you and or the information that could be providing you. Otherwise, sometimes we can have two lines just like this. And remember, if it has an 89 or it could be a 91 and you're labeling as a 90, so that will be a wrong classification. And then last but not least, we have the straight line. This straight line will give you the hint that it's going to be 180. On that one, there's no wrong assumption. If it's a straight line, it is considered a 180. So all of these angles that we're talking about, it comes from a circle. And in a circle, this is the straight line that we have here. So this is the sum from 0 to 180 degrees. It's considered, so the rest, we have the 90 right here, right in the middle. And then we have more angles. So if you see, we're working right now with half of a circle. In case you were wondering where you have seen them, well, everything is thanks to the circles. Then we have these angles. These are congruent angles. Two angles that have the same measure are congruent. So if you see, they must have the same answer. Remember, congruent means that they are equal. And this is the symbol that you will use, the equal with a wavy line on the top. They are going to be identical to each other. It can be 43.2 and this one just 43. Both of them have to be this, they must have the same information. Let's go to this next slide. Angle bisector. a line or ray that divides an angle into two equal parts. So when we're talking about bisectors, just remember this BI. BI stands for 2. And when it's 2, it has to be two equal parts. And this is a sketch representation about the angle bisector. Whenever you hear or read the word bisector, always remember that if this measures, let's say this was 60, the angle in total was 60 degrees, and this is the angle bisector. This is the famous angle bisector. So it's cutting into equal parts this angle and this other one. So the sum is 60, but they split it into equal parts, so it's 30 degrees. And this line, that is how you're going to be representing it with this little tick to know that this is telling you that this angle is congruent to this angle. Just a definition that we went over by explaining it. So this was angle bisector. Now let's go to the following. Adjacent angles. Two angles that share a common side and vertex next to each other. If you see, we have these two lines, these two rays joined in the middle by the vertex, and then from the middle, it's not going to be exactly in the middle. We can't assume that. Why? We can't assume that because we're not given the information like the other one. They're not providing the little curvy lines here, the arches and the ticks. So it's just adjacent. That means that they're just right next to each other. This is what I always tell my students. Just like you are putting two chairs together, right? And then in between, you're trying to push something in between, something that they could be sharing, both of them. So this is one chair, and this is another chair, and this is another one that is just going through there. So they're going to be sharing this. I don't know, it could be like a tape dividing them, or the fence of a house. There you go. That's a better explanation. This is the fence of one house, and this is the other one. That at a certain point they're joining together, and then this is the other one that is dividing in between one side of the house and one side on the other side. Or it could be like a wall in between your room and the other one, and they're joining at a certain point, the corners, the edges. So that could be one example for adjacent angles. So two angles that share a common side. Okay, the next one, linear pair. We have adjacent angles that are supplementary. Combined, they form a straight angle. So we have a straight line and we have a ray in the middle, but it's not exactly in the middle. It's just between these two rays. Okay, this is one ray that was accidentally cut right here, but it's not a bisector. It's just a line that is touching the straight line. But remember that I told you, whenever you see a straight line, the measurement will be 180. So this is a perfect example. Just remember, you have a straight line and then you have one ray. This is a ray again. So then the sum, it's going to be 180. So 110 plus 70 will give you 180, because we have this to be adding again 180, and then we add these two because they are right next to each other. And the angle 110 and the 70 are sharing the ray that we have in the middle. What else? Supplementary angle. This is another clue that I have here, supplementary. In case you don't know, that is, I'm going to write it here for supplementary. If you don't remember what is supplementary, just join the edges or of the S, and it forms like an 8. So that could give you a hint that you're talking about the angle of 180 degrees. Just for you to know, a tip. We have vertical angles, two angles directly across from each other. Two angles directly across from each other on intersecting lines, always congruent. Oh, this is okay, just a couple, I did a replica on this one. So, okay. So vertical angles, guys, it is exactly two lines that we have here. They're just intersecting lines. And they're telling us they're always congruent. That means that this angle is congruent to this angle. And this angle is congruent to this. So now this is another mark that is known for to indicate that they are congruent. So with one arch, these two is a set that they're congruent to each other. And these two arches, it is congruent to this other one. That's another way to remember, like in like an X. It looks like an X. These are the vertical angles. Try to remember them. So yeah, that's it for today on this for this example. Let me go to number 8. Complementary angles. Here we have complementary angles are two angles with measures that sum to 90 degrees. Okay, do not have to be adjacent. They don't have to be adjacent. It's just a broken line, well, excuse me, a line that is going through here. Sorry for that. It's a line that goes through here. And they're just giving me, see, I have another little square here. With this, I know this is equals to 90 degrees. And it's just a sum of two angles. 55 plus 35 will give you 90. And another way to remember complementary, look at the C. I connect the end at the starting point. I get a 9. So that one likely could give you a hint that we are speaking about 90 degrees. Have to erase everything. And last but not least, we have supplementary angles. Two angles with measures that sum to 180 degrees. They do not have to be adjacent again. So this was split. So you can see that this is the sum of 120 and the 60. If you see also, it sometimes, like it's a supplementary, here it's the 8. So the sum is going to be 180 degrees. So also you could have a straight line. Let's say you want to join these two. So this is more or less like through here. So this is the 60 degrees. And the other side will be like around 120 degrees. And obviously this is in a broken way. 120 plus 60 will give you 180, and this is 120 and 60 degrees. Okay, guys. So hope that you understood this lesson. It's super easy, and it's just vocabularies that I will ask you not to forget at all. Keep them in mind, and they will be very helpful to solve the problems that we will be covering in a few days. So thank you very much. And every time you need to refer to this and just pause it and then go and fill in and classify your angles that you're doing with the assignment. Thank you.